Welcome to the Balsa Wood Glider skills task. In this video we're going to go through what the task involves and what you need to do to be successful in this task. So you've been doing some work in Fusion 360 and learning some skills in that. This task gives you the opportunity to demonstrate those skills in Fusion 360, which is also known as a CAD program, and also gives you an opportunity to go through and demonstrate design thinking. What you're going to be doing is designing a balsa wood glider that can be cut and engraved using the laser cutter we've got. What you need to do to start with is to decide whether you're going to build a long distance glider or a stunt glider. The choice is up to you, so you can make it whichever one you like. It's not going to be as the whole class needs to do a long distance or the whole class needs to do a stunt glider. It's entirely up to you. Once you've chosen if you're going to do a long distance or a stunt glider, you need to reword the task using your own words, but you need to incorporate either long distance or stunt glider, depending on which way you go about it. So that's the first part, what you need to do. From there, you need to research what characteristics your chosen glider needs to have and why they need to have it. For example, are the ailerons up or down, or both for barrel rolls or loop-the-loop? And also, you need to look at what forces will the glider experience. And do you need to make these maximized or minimized? So have a look about what are forces, alright? This is part of the engineering aspect of it, where engineers look at a lot of the physics that goes on behind things. You also need to discuss why you're going to use a laser cutter to produce your product over manually cutting it out with something like scissors or a scalpel or Stanley knives. Develop a timeline of what you hope to achieve in each step of the process and when. For example, by the end of this week, I'd like to have the designs done, or by the second lesson next week, having started some of the design in Fusion. So make sure you start to list those things out and actually think about, is it going to fit in, or what checkpoints do I need to meet to ensure that I meet the due date. You also need to judge if how your glider is going to meet the design brief. So how will you know if your glider has been successful or not? Some of the restrictions that you need to adhere to. So listed here is the maximum dimensions, so the width, length and height. The time frame, you need to check on Daymap for when this task is due. You've also got two thicknesses of material. You've got 3mm and 1mm. The 3mm will make up the main fuselage of the plane, while your 1mm will make up the wings. The next step in the process, you have to sketch out at least 4 different designs from top and side views as a minimum. From here, once you've got your 4 designs, so 4 designs, top and side views, that's at least 8 different sketches. You need to evaluate what one you like best and why. So some guiding questions to think about: what makes design A better than design B? Design C will help achieve my goal of stunt distance because X, Y, Z, or give me an explanation as to why it will help that. Remember, for your designs, it should be to scale, alright? So I'm not asking you to make it exactly to scale, but try to make it look like it's to scale. Also remember, you can add text and images to your designs when we go through and process it later on. You can add in text and imagery to your final design to be laser cut. So we can actually engrave text and images onto there. A word of warning with images: simple images work well. More complex images do not show up as well as what others do, as well as what the simple images do. Once you've got your final design, you can begin creating it in Fusion 360. If you don't have your designs done and are jumping into Fusion, you're missing the designing step, which is a significant part of your final grade. As you're going through designing it in Fusion, you need to take screenshots of your work along the way, noting down what each screenshot represents. This forms part of your folio to demonstrate how it's been made. If you decide to make any design changes along the way, you need to document this and make it and tell me why you've decided to make that design change. Once you've got your final design, you need to export each part as a DXF file, and then you can add your text and graphics in Adobe Illustrator. You will also need to export a technical drawing of your final glider. I'll show you how to do this in class. Finally, you do your evaluation. So thinking back to your design brief, did the glider set out what you wanted it to? So if you were trying to achieve a long distance glider, did your glider achieve that? Those changes that you made along the way and that you've documented, talk about those. If you were to do this task again, what would you change next time and why would you make those changes? Survey your classmates. What do they think of your final design and the performance of it? And finally, don't forget, this is a task around demonstrating your CAD skills. So how did this task build on your skills in CAD? I've got here the marking rubric, so have a look through that. You can pause the video if you like. Otherwise, this is available in the little workbook that I've made up for you guys also. And finally, some vocabulary. You'll notice that throughout the task, there are some words that have been highlighted. So here, those highlighted words will give you an explanation for that. Links to the Australian Curriculum Achievement Standard and content descriptors, which need updating. So, if there's any questions, daymap, message, email, ask in class, all of that kind of stuff, you guys know the drill from there. I'm going to spend a couple of minutes now and go through the workbook, or at least introduce that to give you guys a platform to be able to put in all of your information. So this is the workbook. So first of all, put your name on it. Again, just some instructions on how to use this. Each slide should have minimal text on it. Use the notes section for the bulk of your information that you would otherwise say in a presentation. What I'm getting you guys to do with this is to do it as a multimodal presentation. What this means is, if you were to then turn around and present this to somebody as like an oral presentation, what would you be saying? Whatever information that you're going to say, have that in your notes section, and then leave the text that's on screen to be minimal. For this document, make sure that you're adding in information to it continuously. This is, as I said, the workbook for this task. If you want to, you can record your presentation and use voiceovers if you wish. I would prefer if you guys did that because it develops your multimodal skills, especially heading towards Year 11 and Year 12, where SACE are putting a emphasis on developing those multimodal skills for assignments. And please delete this slide before submitting it. This will definitely show who listens to the task, or who listens to the video and who actually reads through the workbook. So, introduction here, design brief, designing, so take photos of your sketches, put them in, and same again. Implementing, so your screenshots, your copy of your technical drawing, your final design, take a photo of it once it's done, your evaluation, and give me a final quote. So that's it. That's all there is to this task, guys. If you have any questions or comments or anything, please let me know, and I will do my best to answer them. Thank you for watching. I know this video has dragged on for long enough, but it is an involved task, but I hope you guys have fun doing it. Bye for now.